Okay, so in the last video we were talking about the electromagnetic spectrum, and in this video we want to tackle exactly how that relates to the greenhouse effect. And so we started with this kind of complicated figure, but it shows a lot. Really, everything we need to know about the greenhouse effect is contained within this figure. And so the electromagnetic spectrum is shown on the horizontal axis. We have the infrared spectrum out here, the visible spectrum here, and then the ultraviolet spectrum there. Okay, and so these curves at the top are the spectrum of light, or of radiation rather, that is emitted from an object at these given temperatures. This is 5,525 degrees Kelvin, which is approximately the surface of the sun. And these are 210 to 310 degrees Kelvin, which is more or less the range of temperatures we experience at the surface of the Earth. Okay, Kelvin, again, is just the absolute temperature scale. It's degrees Celsius minus 273, or rather the opposite. 273 minus the degrees Kelvin will give you Celsius. So 310 is around almost 40, 37 degrees Celsius, and this is down in the negative 50 range. And so that covers broadly the range of temperatures we experience on the Earth. And so both objects are emitting radiation. Visible light primarily is coming from the sun, whereas infrared radiation is being emitted back out to space by the Earth. Now, different gases have the ability to absorb and re-emit different wavelengths of radiation. It has to do with the specific size, spacing, and geometry of the molecule itself. And so you can see down here at the bottom, water vapor has the ability to absorb a lot of radiation across a wide range of the spectrum, especially down here in the infrared, which is really what the greenhouse effect is. Okay, carbon dioxide also absorbs down here in the infrared, and several other greenhouse gases. But what I said in the last video was that a greenhouse, a physical greenhouse where you grow plants in the wintertime, it works because glass allows visible light to pass through, warming the surfaces inside the greenhouse, which then emit infrared radiation back out, warming the air. But that infrared radiation gets trapped by the glass because infrared can't pass freely through clear glass like visible light can. And so that heat energy is trapped in. It's a perfectly reasonable question to ask, well, what does it mean to heat the air? That's something that I don't think people generally would ask themselves, but it's a reasonable question. What is it about the air that feels warm to us when we are in a warm room? Well, it turns out that it's these molecules that have the ability to absorb and re-emit infrared radiation, because infrared radiation is sort of the heat currency of the universe. Heat energy is transferred through infrared radiation. And so the air, specific molecules within it rather, like water vapor, carbon dioxide, methane, nitrous oxides, other things, chlorofluorocarbons, there's a number of different compounds, but the most relevant ones in the environment are water vapor and carbon dioxide, really, and methane to a lesser extent. Those molecules absorb infrared radiation and then re-emit it in every direction. Okay, and that warms things around it. And so if we're sitting in a warm room, that warms us. But if we think about the planet as a whole, that keeps some of that energy in. So energy comes from the sun, primarily as visible light. It passes more or less freely through the atmosphere. This panel here is just the total absorption and scattering by the atmosphere. And you can see a lot of visible light gets through, right? We can see out into space at night anyway. We can certainly see the sun during the day, but you can see the stars at night. Visible light passes through more or less freely, unless there's things like dust, other obstructions, clouds obviously. But infrared radiation doesn't pass freely, right? Not nearly as freely anyway. These filled in parts here are the amount of the line that represents the emission from that surface. It's the amount that comes in at the surface that we receive, or in this case, the amount that makes it through the atmosphere back out to space. And you can see that a lot of the total energy, the area under this curve, is blank, and it's because these gases like water vapor and carbon dioxide, are absorbing that energy before it can make it out of the atmosphere. Okay, so that's what creates the greenhouse effect. It's really critical that we understand that in order to understand how this residence time comes into play, and how this really dictates global temperature. Yeah, so we'll move on with the global energy balance from here.